You think space is empty, not metaphorically empty, actually empty, nothing there, no stuff, no influence, just a silent gap between real things. You picture atoms as islands, planets floating in a void, galaxies sprinkled through nothing. This picture feels obvious, it feels safe, it feels like common sense, but that picture is wrong. You imagine emptiness as the absence of everything, as a background that does nothing, as a stage that doesn't participate. That intuition has been failing you for a long time. Because when physicists look at nothing, they don't find nothing waiting patiently. They find activity where there should be none, effects with no visible cause, energy where energy should not exist, not chaos, not magic, something quieter, more unsettling. Space refuses to behave like emptiness, and the disturbing part isn't that we don't fully understand it. It's that we don't even agree on what empty is supposed to mean anymore. You were taught to picture space as a container, a box, a background, a place where real things happen. Remove the planets, and you imagine the box still there. Remove the stars, and the box remains. Remove the atoms, and you expect what's left to finally be nothing. This picture feels so natural that you stop questioning it. You talk about objects in space the same way you talk about furniture in a room. The room itself is not the story, the furniture is. This is wrong, not because it's careless, because it's inherited. Every diagram you've ever seen encourages it. Dots floating in black, arrows pointing through emptiness. A grid that politely stays out of the way. The grid is never questioned. The black background is never discussed. Space becomes the silent assumption behind every explanation. But the moment you try to remove everything, the illusion begins to break. Imagine stripping the universe down piece by piece. No air, no dust, no radiation, no atoms vibrating, no light passing through. You expect silence. What you're really doing is imagining the removal of things, while quietly keeping the stage they stand on. That stage feels untouchable. It feels neutral. It feels exempt. And that exemption is the mistake. Because when physicists talk about empty space, they don't mean what you mean by empty. They don't mean a void left behind after subtraction. They don't mean a passive gap between objects. They mean a state, a condition, a definition that survives even when nothing else does. This difference matters because subtraction alone never gets you to true emptiness. You can remove particles. You can remove fields. You can remove energy as far as classical intuition allows. And yet something remains not because you failed to remove it, but because the idea of removal no longer applies. Your mental picture assumes emptiness is what's left over. Physics treats emptiness as something you arrive at intentionally. A baseline, a reference state, and already that should feel uncomfortable, because baselines can have structure. Reference states can behave. Conditions can change outcomes. The illusion of empty space survives because it never has to defend itself. It hides behind familiarity, behind language, behind the comfort of nothing to see here. But once you stop treating space as a container, once you stop assuming it does nothing, the entire picture begins to wobble. Because containers don't push back, backgrounds don't interfere, nothing doesn't leave fingerprints. And yet empty space does. Your intuition draws a hard line. Something can cause effects, nothing cannot. This feels so obvious that it barely feels like an assumption. It feels like logic itself. If nothing is present, nothing should happen. Physics disagrees, not loudly, not dramatically, quietly, persistently, with measurements. Imagine two perfectly smooth metal plates, flat beyond anything your hands could feel, placed extremely close together, facing each other in a vacuum. No air, no heat, no particles bouncing between them. By your intuition, nothing should happen, but the plates move. They drift toward each other, slowly, predictably, as if pushed by something you cannot see. This is not a thought experiment. It is measured, repeated, verified. If you insist that nothing exists between the plates, then nothing just exerted a force. This is the moment where intuition starts to fracture. You might try to rescue it by saying, well, maybe something tiny is still there. That escape doesn't work. The experiment is designed to remove everything removable. No classical particles, no radiation, no hidden breeze of influence. And still an effect remains. Physics doesn't say, surprise magic. It says something more disturbing. The emptiness itself is involved. The force does not come from the plates. It does not come from outside interference. It emerges from the conditions of space between them. Your intuition wants to blame leftover clutter, but the equations don't. They treat the vacuum not as absence, but as a participant whose behavior changes when constrained. This is wrong according to common sense. Nothing should not care about geometry. Nothing should not respond to boundaries. Nothing should not notice when you bring two plates close together. Yet the vacuum notices. Change the distance between the plates and the effect changes. Rotate them and nothing new happens, but the force remains. Remove the plates entirely and the effect vanishes. This is not an object pushing. It is not a field leaking in from somewhere else. It is emptiness reacting to conditions. At this point, physics does something unsettling. It stops asking, what is pushing, and starts asking, why does empty space have rules at all? Because rules imply structure. Structure implies organization, and organization does not belong to nothing. The moment nothing begins to care about arrangements, your old definition collapses. You can no longer say emptiness is just the lack of things. Lack does not behave. Absence does not generate forces. Yet here is a force measured in laboratories, produced by space that supposedly contains nothing. This is not a glitch to be ignored. It is the first sign that emptiness is not what you thought it was. And worse, this is only the shallow end. You want emptiness to be calm. Even after admitting it can produce effects, you still imagine it as mostly quiet, a background with the volume turned very low. That instinct is understandable, because if nothing is allowed to be active, then the word starts to lose meaning. Physics doesn't let you keep that comfort. In modern theories, the vacuum is not defined as nothing there. It is defined as the lowest possible energy state. That sounds safe. Lowest energy suggests stillness, a system with nowhere further to fall. This intuition is wrong. Imagine a pendulum hanging motionless, at rest, no swinging, no movement. Classically, this feels like a perfect analogy for emptiness. But at a deeper level, physics refuses to let anything be perfectly still, not because of disturbance, not because of measurement, because stillness itself is forbidden. Even in the lowest energy state, the system cannot freeze completely. The vacuum, by definition, cannot sit still, not dramatically, not explosively, but restlessly. Energy fluctuates not as particles popping in and out like fireworks, but as unavoidable uncertainty baked into the structure of reality. This is where language starts to betray you. Physicists talk about fluctuations, and you imagine motion. But what's fluctuating is not stuff moving through space. It's the values that define the vacuum itself refusing to settle. Even when nothing is happening, something is still uncertain. and uncertainty has consequences. You don't see these fluctuations directly. You see their fingerprints. They shift energy levels. They alter forces. They slightly change how particles behave near nothing. If the vacuum were truly empty and inert, these effects would not exist. You might try to reinterpret this as a mathematical artifact, a bookkeeping trick. That defense has failed. The predictions match experiments with uncomfortable precision. Remove the fluctuations from the equations and reality stops lining up. The vacuum is not buzzing with hidden particles. That picture is too literal. It is worse than that. The vacuum is a state that cannot fully define itself. It is constrained by rules that prevent perfect emptiness. No matter how carefully you drain the universe, you hit a floor you cannot break through. Not a wall of matter, a rule, and rules are not nothing. This is the moment where emptiness stops being a place and becomes a behavior. The vacuum doesn't just exist. It responds, it resists. It refuses to vanish completely. Your intuition wants emptiness to be the end of the story. Physics treats it as the beginning of a problem. And once you accept that the vacuum cannot rest, you are forced into a deeper question. If nothing is restless, what exactly is it that's refusing to disappear? At this point, the word empty is barely holding together. You've already accepted that space can produce forces and that its lowest energy state is not truly still. The natural escape is to say this: fine, space contains strange things, but space itself is still nothing. That separation feels clean. Contents versus container, actors versus stage. Physics does not respect this boundary, because once emptiness has behavior, it must have properties. And properties do not belong to nothing. Start with something deceptively simple. You move through empty space in a straight line. At least you think you do. But when mass or energy is nearby, that straight line bends. Not because a force pulls you sideways, but because the definition of straight has changed. This is wrong according to everyday intuition. Straightness should not depend on surroundings. Empty space should not curve. Yet space does, and it does so without adding substance. No medium, no particles filling the void. The geometry of space itself changes. This is not an analogy. It is not a visualization trick. Distances behave differently. Clocks tick at different rates. Paths that should be shortest no longer are. These are not properties of objects alone. They belong to the space between them. Once you accept this, the container metaphor collapses. Containers do not stretch. They do not warp. They do not store influence. Space does all three. You might try to rescue the idea by saying space is just a set of relationships between objects. But this fails the moment the objects leave. Gravitational waves travel through regions with no matter at all. Ripples move through emptiness and carry energy across vast distances. If space were only relationships, there would be nothing left to ripple. Yet the ripples arrive, they distort distances, they change the timing of clocks, they pass through nothing, and still do something. At this point, emptiness has accumulated an alarming list of traits. It can bend, it can transmit effects, it can store energy temporarily, it can react to constraints, but it still is not stuff. And that is what makes this uncomfortable, because physics is not saying space is a substance. It is saying space behaves like something real without being made of things. This is a category problem your intuition was never built to handle. We are used to properties belonging to objects. Mass, charge, temperature. Here, the properties belong to absence, not metaphorically, operationally. Measured, tested. used in predictions. The more carefully you examine empty space, the less it resembles a background. It starts to look like an actor that never steps on stage, but quietly rewrites the script anyway. And once space has properties, a dangerous implication follows. If it has properties, it can carry energy, which brings you to the problem physicists least like to talk about. Energy is supposed to be conservative. It comes from somewhere. It moves from place to place. It never appears without explanation. This rule feels foundational. So foundational that violating it feels impossible. Empty space violates it quietly. If space has properties, those properties must correspond to energy. Not kinetic, not thermal, something deeper, vacuum energy. The name sounds harmless, it is not. Because when physicists calculate how much energy empty space should have, the answer is absurd. Not slightly wrong, not off by a factor of 2. Off by a number so large it barely fits into language. Theoretical predictions overshoot observations by something like 10^2. This is not a typo. It is the worst prediction in the history of physics. If the vacuum contained the amount of energy theory suggests, space would tear itself apart instantly. Galaxies would never form, atoms would not exist, and yet here you are. So something is deeply inconsistent. Either the calculations are wrong in a fundamental way, or empty space contains energy that almost completely cancels itself out for reasons no one understands. This is not a small technical problem. It sits at the intersection of quantum mechanics, gravity, and cosmology, the 3 pillars of modern physics. Each pillar works brilliantly on its own. Together, they disagree violently about emptiness. You might expect physicists to avoid this contradiction. They can't. Vacuum energy shows up experimentally. It influences the expansion of the universe. It contributes to observable effects. You can't remove it without breaking everything else. But you also can't explain why it is so small. Empty space, it turns out, has an energy budget, and no one knows where the accounting went wrong. This forces an uncomfortable shift in perspective. Energy is no longer tied exclusively to objects or motion. It becomes a feature of the state of space itself. Not energy in space, energy of space, and that distinction matters, because if space itself carries energy, then the vacuum is not a neutral baseline. It is a loaded condition, a tension, a suppressed imbalance. The universe is not expanding into nothing. It is evolving according to the properties of what we once called nothing. At this point, emptiness is doing too much to ignore. It influences forces, it refuses to rest, it curves, it carries energy, and yet every attempt to define it precisely breaks something else, which leads to the most revealing failure of all. Physicists cannot agree on what empty even means. By now, emptiness has accumulated too many responsibilities. It behaves, it reacts, it carries energy, it shapes outcomes. So you ask the reasonable question, what exactly is empty space? Physics does not give you a clean answer. Not because it hasn't tried, because every successful framework defines emptiness differently. In quantum field theory, the vacuum is a state, the lowest energy configuration of fields that exist everywhere. Even when there are no particles, the fields remain. So empty means unexcited, not absent. In general relativity, emptiness is geometry, a structure that can curve, stretch, and ripple even when no matter is present. Here, the vacuum is not about energy states, but about how distances and time behave. In cosmology, emptiness is something else again. It becomes a driver of expansion, a background pressure that accelerates the universe. Same word, different meanings, all experimentally successful. This should worry you, because definitions are supposed to converge as understanding deepens. Here they diverge. Each theory insists it knows what emptiness is. Each one breaks when pushed into the other's territory. Try to merge them, and contradictions explode. The vacuum in one theory is unstable. In another, it is dynamic. In a third, it is a constant whose value nobody can derive. None of these descriptions are wrong. They all work. They just do not agree on what nothing refers to. This is not a linguistic problem. It is a structural one. Physics is built on operational definitions, what you can measure, predict, and test. And operationally, empty space behaves differently depending on which tools you use to probe it. There is no single observer, independent notion of emptiness that survives all scales. At small scales, emptiness fluctuates. At large scales, it drives cosmic behavior. At intermediate scales, it bends trajectories and delays clocks. The idea that nothing is simple has quietly collapsed. You are left with a strange situation. Physics can predict the behavior of empty space with astonishing accuracy without agreeing on what it is. This is not a temporary confusion. It has survived decades of refinement. The more precise the theories become, the less unified the concept of emptiness appears. And that forces a final shift in perspective. Maybe emptiness is not a thing to be defined. Maybe it is a limit that behaves differently depending on how you approach it, which leaves you with a deeply unsettling possibility. The universe may not be built from things at all. It may be built from structured absence. You began with a simple picture, objects floating in nothing, things surrounded by emptiness, reality built from what exists. That picture no longer survives, because the more carefully physics examines absence, the more it behaves like a foundation, not a substance, not a medium, a condition that refuses to be trivial. Empty space is not what remains after everything is removed. It is what remains even when removal no longer makes sense. It has rules, it has limits, it has consequences. And the most unsettling part is not that we don't understand it yet. It's that emptiness might not be the opposite of existence at all. In every theory that works, what we call nothing is already structured, already constrained, already capable of influencing outcomes. There is no clean boundary where being stops and nothing begins. Only a gradual thinning of description until you hit a state that still does things but no longer contains things. This forces a reversal of intuition. Instead of objects giving meaning to space, space gives meaning to objects. Particles are not guests in emptiness. They are excitations of whatever emptiness already is. Remove them, and the stage does not vanish. It continues quietly, according to rules we did not invent. And this reframes the oldest question in physics. Why is there something rather than nothing? The question assumes nothingness is the natural default. Physics suggests the opposite. Nothingness may be impossible, not philosophically, physically. The universe may be unable to turn itself off, unable to reach a state without structure, unable to achieve true absence. What we call empty space might be the most minimal form reality can take. A restless baseline, a structured silence, not a void waiting to be filled, but the condition from which filling becomes possible at all. And once you see that, emptiness stops feeling like the absence of reality. It starts to feel like its deepest expression.